my mic control. I'm not, because I don't teach here, so I'm not very serious about things. But if this would have happened to me in back home, back in Canada, then I'll be definitely mad. But unfortunately, I can't do anything about it. I think some of the students are already gone because they have their own commitment starting at 12 o'clock. So some of you were taking the NMR exam?
Yes.
How was the exam? Not good? Because of you guys, it was delayed.
Yeah.
Only three students took the NMR exam? 4? And the NMR was not good, the test was not good. You'll be able to pass it?
I mean, it was more chemistry related compared, and we were.
Yeah, NMR is all chemistry, isn't it? Because Dr. Iqbal is a chemist basically, so he'll be teaching, giving his basically chemistry concepts.
But last year, bio paper was different and chemistry paper was different.
Oh, there are two different
But
papers.
this time, combined.
Or they use the same paper for both. But you know, in chemistry, do they teach you about use of proteins, how you can determine the structure of proteins using NMR?
In STD NMR.
But they teach you this? So you know how to use NMR to find out the structures of proteins?
No, STD we don't teach, but STD in our in our thesis and our research.
No, but not as a part of this course. So you don't know how to determine protein structure using NMR. No.
Actually, we need in our field, but we have to know that in the basics. We took the class, we take know the basics.
But you didn't get it. You didn't get the basics. But you know, I'll tell you one thing, that the NMR is for protein structures in biology. When I was doing my PhD here, at that time, NMR was something organic chemistry thing, right? And all of our organic chemist colleagues, they were very good at NMR. We never thought of and used and think of NMR can be used in biosciences. But now, NMR is more used in biosciences. And NMR is a very hot technique to learn, determine and sequence the structure of proteins, to find out the quaternary structure of proteins. Any idea about quaternary structures? What is it?
All the surveys,
Everything.
Here that's the 4 levels of protein structural organization. What are 4 levels?
Primary, secondary, tertiary, and quaternary.
Tertiary and quaternary. So, what is the difference between tertiary and quaternary structure?
Tertiary, the quaternary is the combination of different.
Mixed what?
Sub-units.
So you know any protein which is consisting of only one subunit can have a quaternary structure? No? What do you think? A protein is consisting of only one subunit, one chain, can have a quaternary structure? Why? Why they don't have a quaternary structure? Yeah, we just talked about the 4 levels of structural organization in proteins, right? So why a protein with 3D structure cannot have a quaternary structure?
It should have 4 subunits.
The protein should have 4 subunits for what?
Or quaternary structure.
Yes, so quaternary structure, the definition is not all the proteins have quaternary structure. Even if you have determined their structure up to the finest level, still they cannot have a quaternary structure. The definition of quaternary structure is when a protein is consisting of more than one subunit and how these subunits interact with each other. For example, and I'll give you the example of 2 proteins today. One is myoglobin and the other is hemoglobin. Myoglobin, any idea about the structure? How many chains are there?
4.
Myoglobin.
4.
No.
One subunit.
It has one subunit, one chain consisting of. And hemoglobin?
4 subunits.
And then myoglobin has a tertiary structure.
Yeah.
And the tertiary structure of myoglobin chain is identical to one of the chains of hemoglobin. Myoglobin can have a tertiary structure but no quaternary structure. Hemoglobin can have a quaternary structure. Why? Because it is consisting of more than one subunit. Right? So I teach my students how to use NMR, X-ray crystallography, and cryo-electron microscopy to find out the structure of protein. It's a very important technique, difficult to learn, but if you master that technique, chances of finding a job are very high because this job is high in demand. It's very rare to find people who are expert in using these techniques to find out the structure of proteins. Right? So if you have got an opportunity to learn about NMR here, take this opportunity. I'll miss it. Because when we were studying here, NMR was a non-existing thing for bioscience scientists, right? So that's why we didn't learn anything about it, and it was not included in our courses. But if you are getting the opportunity to learn about NMR, it's very good technique, right? So try to learn the basics of that NMR. In our department, you won't believe for how long we are looking for an expert who can, who knows how to operate the NMR machine that we have in our department, and we are having hard time to find someone. Right? So these techniques are very, very good. Okay, today's is the last class. And I think out of all the 3 classes that including this one, I've been teaching, this is the most fun class because here we learn exactly what the homology modeling and the molecular docking is. Obviously, I cannot teach everything in just 1.5 hours, especially at this time. When some of the students are already exhausted after the lecture, after the exams, and some of you have to come back again once, because in the morning usually we are fresh, right? At this time it's exhausted, but still I'll try my best to include jokes here and there, whatever I remember. I don't remember, I think is there any joke in this today's class. Okay, the today's class is about, what we have learned already in exercise 1. I gave you a protein amino acid sequence, you use that sequence, and in just 1 or 2 steps by using 1 or 2 databases, you learn so much about that protein, right? So this is, and I'm not teaching you how to design a project based on that, I'm just teaching you how you can use and explore these databases. But when you design a project, you can include these steps in your project, And there are tons of proteins, millions of proteins out there. We know their sequences, but we don't know their structures. Any idea why we don't know their structures?
Because no studies have been done on NMR or X-ray crystallography.
Because the NMR, X-ray crystallography, cryo-electron, they are very expensive, labor-intensive, time-consuming techniques, right? It's easy to sequence the proteins, but it's very difficult to find their structures. The sequences are already there in different databases. Scientists, whoever working on whatever project, they just pick a particular amino acid sequence or protein and they work on it, right? So as such, we don't have any general mechanism where people are working in isolate and trying to find out the structure of proteins. So there are millions of proteins out there from the living system, and we just know their sequence, we don't know their structure, we don't know their function. So imagine how much potential is there for you guys. If you learn these skill sets, some of the tools I mentioned through this course, just imagine the potential for you guys. So you can have your own startup company and start offering these services to the academic scientists and the industrial scientists. So we have learned about this one in the first exercise. I did not teach this one because it's almost a kind of replica of the same thing, and I don't want you guys to get bored. So here I told you about the R programming and the Python in the second class. Third class is about the Campbell database. In Campbell database, we learn about the different ligands that have been reported against your protein of interest, right? And how can you find out what compounds have been, rather than you do individual searches, go to PubMed, writing the name of your protein, and different keywords, and then one by one manually search the compounds which have been reported against your protein and make a list of those compounds. Here through this database, you just need to write the Uniprot ID of your protein, and immediately you will see how many ligands have been reported against your protein, right? And in which capacity, as a drug, as toxic molecules, as inhibitor, as a stimulator, as agonist, as antagonist, whatever capacity and what concentration. But we'll talk about this as we move on. The last one is the 3D structure and sequence comparison using homology modeling as well as the docking through Chimera. So today's class is about basically these 2 programs I'll talk about. One is the Swiss model. Swiss model is called homology modeling server. What is the difference with this? It's a database. You go to the database, it contains the built-in tools. It contains a built-in software. It contains a built-in server. You don't have to download anything. You don't need to connect to anything other than internet, right? And here you just write down the sequence of your protein, whatever you have available, and you don't know anything about it. You want to know how the structure should look like. So imagine on one side you have NMR and X-ray and other techniques which takes you months to work on and then get the 3D structure of your protein, and you still have any doubts. Here, within few seconds, you copy the sequence and you get the structure immediately of your protein, right? So this is through this Swiss modeling. The database is basically a homology modeling server, and it gives you the structures based on 3-dimensional protein template models, and it has different, and it can integrate this database can integrate and communicate with other databases. As I mentioned, all the databases they communicate with each other. Rest of the things I already mentioned. I just don't want